Hello, everyone, and welcome back to the book reading session with Tensorflow user group Chandikar. And we are continuing our first chapter from the book AI and Machine Learning for Coders by Laurence Moroney. So, we left at getting started with machine learning, and so we are here. Let us consider the two sets of numbers x and y. So as you can see, there is some relationship between x and y. For example, when x is minus 1, y value is minus 3. Similarly, when x is 0, y is minus 1. When we see there is a pattern between these numbers, so we can say that y is 2x minus 1. That is, if you put x is equals to minus 1, the value of y would be minus 3. Now, as we see that the hypothesis that y is 2x minus 1 fits well, and it's time that we convert it into a form of code. So, as we have discussed earlier in the previous video, we'll be using Keras APIs with TensorFlow. So, if the code does not make sense for now, let's just go line by line, and then we'll do a quick collab session where we'll understand what this code means with each and every line. If you have heard of neural networks, you've probably seen this diagram before. So it's a basic neurons connected to each other. It's called a dense layer or a neural network. So each of these circles is called a neuron, and each neuron is connected to each and every neuron in the next layer. As you can see, the input arrows show the input coming to the outermost layer of the neurons, and which input is transferred to the inner layer of the neurons, the neural network, and finally we get our two outputs from the last two neurons of the network. These circles, which we call neurons, and each of the columns, we call them layers. So in this diagram, we can see that there are three layers. First layer has 5 neurons, the second one has 4, and the last one has 2 neurons. The first line, when we look back to the code that was given, that was here, we can see that we are importing TensorFlow as TF because, as I said earlier, it is really difficult to call upon TensorFlow each and every time. So we use a short form TF. Then we import a library called NumPy, which is basically used for all mathematical functions. Then we import from Keras, we import sequential. Then we import layers, that is dense, because as we have seen in the previous diagram, there is a dense network of neurons and they are separated by layers. So there were 3 layers and it was a dense interconnected neuron structure. Then we need to define a model because of course we're training a model. So we need a model to train for, and the model is trained model we define sequential, and dense the number of units, that is the number of neurons that we need, and what kind of input shape we'll be giving. So as you've seen earlier that x is a single value, each time we're giving a single value, so input shape is 1. Then to compile the model, we need some optimizers. Here we are using stochastic gradient descent. We'll be learning more about it in the coming videos. Then we need to understand the kind of loss, if the model is predicting right or what is it deviating from the actual path. So we are using mean squared error for that. And finally, we are converting our given data into a form of NumPy arrays because it's much easier to work with them as we are using NumPys, and it is a function which is mostly known for mathematical calculations. Finally, we fit the model with providing the input, outputs, and number of epochs, that is the number of times the model runs through each layer. And finally, we print out the what's the prediction of the model for an unknown number that has not been ever fed to the model, like value of x is equals to 10, we want to know the value of y, which was not earlier provided in the input. Now, as we see, model is equals to sequential of dense, units equal to 1, input shape of 1. So what does that mean? We'll go a little bit deeper into it. When using TensorFlow, you define your layers using sequential. Inside sequential, you then specify what each layer looks like. So in sequential, you actually want to tell the model how each layer is located and each layer is specified. We only have one line inside a sequential, so means we have only one layer. We're using just one layer because our inputs and outputs are very simple. We don't have much data to work on, so one layer would do it. Then you define what the layer looks like using Keras API. So Keras.layers API is used to define how our model looks like, how each layer we are using looks like. So here we say we are using dense layer, that is fully connected layer, which is what you can see in the previous figure, where every neuron is connected to each and every neuron in next layer. So our dense layer has units equals 1, that is specifying that we have just one dense layer with one neuron in our entire neural network. So we just have one neuron and we'll be training our model on that only. We have one layer that has only one neuron. Finally, we compile our model with model.compile. We provide an optimizer and a loss function. So if you actually want to understand the scenario, here's another scenario. So the computer has no idea what the relationship between x and y is. So we're just giving it raw data and we're asking the computer to suggest what kind of relationship is between x and y. So we're providing x and we're providing y. We're giving it the question and the answer, and we are asking what are the rules. So for example, let the computer say guesses that y is 10x plus 10. That means that now it has to check how good or bad its guess was, right? That it's kind of hit and trial method. So when you have guessed that y is 10x plus 10, you will be putting it all the values that you already have for x and y to see if this whole equation y is 10x plus 10 it holds or not, right? So this option of holding and guessing if we have selected or guessed the right kind of equation means we have to choose a loss function. We have to see whether we are near or very close to the kind of function we are looking for. And finally, armed with this knowledge, the computer can then make another guess. That's the job of optimizer. So optimizer helps to the computer to make guesses until and unless it reaches an optimum solution that correctly or nearly correctly fits the inputs and the outputs. This is where heavy calculus is used, but TensorFlow takes care of it in the back end, so we don't have to work on it. In this case, we picked one called SGD, that stands for stochastic gradient descent, a complex mathematical function that when given the values, the previous guess and the results of the calculating the errors on that guess can then generate another one. So SGD is just giving us another guess. Over the time, it's the job of the its job is to minimize the loss, and by doing so bring the guessed formula closer and closer to the correct answer. Next, we simply format numbers into data format that is expected by the layers. Here comes the library NumPy to use. In this, we convert the inputs and the outputs numbers that we have into a NumPy array so that it is easy to process. The learning process will begin with model.fit. So we have the NumPy arrays for inputs and outputs, and we have the number of epochs, that is 500. You can read this as fit the x's to y's and try it 500 times. So that means that you will try to fit x values to y values for 500 times. It will then feed those results to optimizer, which will generate another guess. This process will be then repeated, with the logic being that the loss will go down over the time, and as a result the guess will get better and better. So here you can see how this thing works in the Colab, and we'll go through it a little later. Here we can see that there are 10 epochs out of 500, and on the right end we can see the loss, and as we can see for the first epoch the loss is around 3.28, and it automatically decreases to 0.96 as the epoch progresses. Now we can also see that till 500 epochs are done, the loss is around 2.61 into 10 to the power minus 5. The loss has gotten so small, means our guess is getting closer to the actual value. Means the machine has learned the pattern between x and y. So it's time to use model.predict to predict for a new value of x that the model hasn't seen before. So here's a note that term prediction is typically used when dealing with machine learning models. Don't think of it as looking into future though. So prediction is used when you are dealing with machine learning model. We are not actually looking into future. So this term is used when we are dealing with certain amount of uncertainty, basically probability. So what do you think the answer will be when the model asks to predict y when x is 10? So if we put it into the value, we'll say that y will be 19. But not exactly. The model won't always give us the value 19. It will pick a value very close to 19 but not exactly 19. There are a few reasons for this. So first is that our loss wasn't 0. So our loss was like 10 to the power minus 5 something, but there was still some loss. So the loss wasn't 0. It was very small, so we expect our answer to be predicted near 19 but not exactly 19. Secondly, the neural network is trained on only a small amount of data. In this case, only 6 pairs of x's and y's. So we don't have a lot of data to train our model upon. So lesser the data, lesser will be the accuracy. The model only has a single neuron in it, and that neuron learns a weight and a bias so that y is wx plus b, where w was 2 and b was minus 1. So this looks exactly like our equation y is 2x minus 1. Here we want to learn that weight was 2 and bias was minus 1. Given that the model was trained on only 6 items of data, the answer could never be expected to be exactly these values, but something very close to them. Run the code for yourself and you'll see what you get. So answer would be around 18.97, and we'll be running this code in a bit future. Seeing what the neural network has learned, so obviously a very simple scenario where we are matching x's to y's in a linear relationship. As mentioned in the previous section, the neurons have weight and bias parameters that they learn, which makes a single neuron fine for learning a relationship, namely y is 2x minus 1. So we have used just one neuron because we have less data and it's really a linear relationship. So we might not be needing so many neurons to fine tune our model. And namely y is 2x minus 1, the weight is 2 and the bias is minus 1. So if you want to see what our model learned, we have to just make few changes to our code. As we can see, the code is same same, but instead of adding dense to the sequential, we're writing it a bit separately because we just want to know what are the weights we get after the model is trained. So in the last line, you can see that we are printing here's what I learned and dot format. So L0 was the dense layer, so dot get weights. So we'll be getting weights after what the model has learned. So weights will be telling us what is the final output. So in the final output, in the very last line, you can see that the array of 1.99, that is 2x, and the array of minus 0.99, that is approximately to minus 1. So the equation becomes 2x minus 1, but this is the approximate. So here this is pretty close to what we'd expected. Y is 2x minus 1, and we could argue that it's even closer to reality because we are assuming that the relationship will hold for other values. Summary is that's the first hello world, and it seems like a massive overkill for something as simple as determining a linear relationship between two values, and you might be right, but this is a cool thing, so that you can understand the pattern of the code and understand as well as create and answer few complex scenarios. So in chapter 2 we'll be learning about computer vision, but now it's time for some code, and we'll hop on to Google Colabs for the code of this chapter 1. Now let's head to the code writing session with Google Colabs. So firstly, I've written here how this whole thing works. First, we need the imports like NumPy and TensorFlow and the frameworks without which we cannot go ahead for machine learning. Then we define our model because firstly, these are the step-by-step manner in which the model is whole defined, compiled, and then it is fit, and finally we can use the trained model to give the predictions. Firstly, we import TensorFlow as TF, so we print the latest version or which kind of version we are using for TensorFlow. So here you can see we are using 2.7.0. That's available with Google Colab. Then we have the values for x and y, and we are finally needing to find the rules for x and y. Now, as we have already seen this code before in the book, we'll be just going through and see what we get when we run the code. So here we were importing NumPy, and from TensorFlow.keras we'll be importing sequential, and TensorFlow.keras.layers we'll be importing dense. Finally, we'll be defining our model like model equals sequential dense units and input shape. Finally, we'll be compiling our model with optimizer and loss function. Then we'll be using NumPy to convert our inputs into form of NumPy array. Then we'll be using model.fit with epochs equals 500. And finally, we'll be making predictions on x is equals to 10. So we'll be running here. So as you can see, the epochs are running, and from starting we see the loss was 0.95 something, and as you see there is a green tick mark on the side, so means the processing is done. And we can see from 0.9 it's gone almost minus 10 to the power minus 5, so loss has decreased many folds. And finally we can see here we have the value of 18.98. So it's approximately 19, touching 19 I would say, but not exactly 19, it's 18.98 because we have very less data to train upon, and we are using probability here. So we'll never get, because the loss function is just guessing, it's a probability game of guessing. Next we have is we want to know what our model learned actually, so we'll be just getting the weights. So let's run this. It's almost same, we've not changed anything. The loss is here and we run it for 500 epochs. So we just run it and see. Here is what I learned is that array of 1.99, that's approximately 2, an array of minus 0.99, that is approximately minus 1. So it satisfies our condition of y is 2x minus 1, with loss being such less as 3.757 into 10 to the power minus 5. So there is still some loss, it's not 0, that's why we haven't got exact 19. We are near to 19 but not exact 19. So here is another thing that I tried myself, was that I've changed the values for x and y, and the model is here, you can see. So when I run this model, yeah, so my equation here was 3x plus 4. So y equals to 3x plus 4 was my actual equation that I used to get the values for x and y that I have provided earlier. And here is what my model has learned is 3x, that's the approximate, and for y it is 4. It's almost approximate to 4, not exactly 4. But the value has to be 34 and it is exactly 34.04. So I can see the model is well trained here. So we are done with chapter 1 coding. All the code we have done for chapter 1. Now we'll move to chapter 2 in the next video, where we'll be learning about computer vision and how we can use computer vision for different projects, and all the code we'll be doing simultaneously in the Google Colab. Thank you.